Salam, peace be upon you. My name is Muhammad Laik Sadiqi, the father of all of Azi, part 54.3 Identifiability versus uncertainty versus underdetermination. We began with pattern itself. What can be compared? What stays the same through change? The fourfold identity gave us the bones. A pattern is itself across transformations, and we can prove it publicly. We learned to measure without smuggling time, to remember without storing the past, to model without confusing map and territory. Part 51 built the firewall between layers. Part 51.5 protected the past from future rewriting. Part 52 reframed error as diagnostic signal. Part 53 taught us to correct while preserving lineage. Part 53.5 gave us a taxonomy of failure. Part 54 taught us that uncertainty is the shape of finite access. Now we must distinguish between different kinds of not knowing. 1. The problem we now face. The map of ignorance. Imagine we are lost in a forest. We come to a fork in the path. We don't know which way to go, but why don't we know? The answer matters enormously. Maybe the map is blurry. We can't read the fine print. Maybe both paths lead to the same destination. Maybe the map is from a different season. Maybe this forest has never been mapped at all. In everyday life, we lump all these together and say, I don't know. But in pattern science, we must be more precise, because what we can do about not knowing depends entirely on why we don't know. If the map is blurry, we can clean our glasses or get a better map. If both paths lead to the same place, we can relax. Either choice works. If the map is from a different season, we need a new map. If the forest is unmapped, we need to become explorers. This is why we need the distinction this part provides. Some things are uncertain. Some are underdetermined. Some are non-identifiable. These are not the same. Treating them as the same leads to confusion, wasted effort, and false hope. 2. What we're distinguishing. 4 kinds of not knowing. Let us name the 4 categories clearly. Measurement uncertainty. The signal is noisy. The instrument is imprecise. The reading has error bars. With better tools, we could know more. Model uncertainty. We have the data, but multiple models could explain it. With more constraints, we might narrow the possibilities. Underdetermination. The evidence supports multiple lawful explanations equally well. Even with perfect measurement, we cannot choose between them because the evidence itself underdetermines the answer. Non-identifiability. The pattern cannot be uniquely recovered in principle under the current access window. No amount of data at this resolution through this window can distinguish between possibilities. These are different. They demand different responses. They imply different possibilities for knowledge. 3. An analogy. The blurry photograph. Imagine looking at the blurry photograph of a distant figure. Measurement uncertainty. The photo is blurry because the camera was out of focus. If we adjust the lens, we can see clearly. The uncertainty is reducible with better access. Model uncertainty. The photo is clear, but we are not sure whether the figure is a man or a woman because they are wearing loose clothing. Different models of human appearance give different answers. With more information, maybe another photo from a different angle, we could decide. Underdetermination. The photo is clear, and the figure could be either a statue or a person standing perfectly still. Both interpretations fit the evidence equally well. Even with a better camera, we couldn't tell without additional evidence, like waiting to see if it moves. Non-identifiability. The photo shows a figure behind frosted glass. No matter how good our camera, We cannot recover the fine details because the glass fundamentally blurs them. The pattern is non-identifiable through this window. Each kind of not knowing points to a different reality about what we can and cannot learn. 4. Another analogy, the locked box. Imagine trying to know what is inside a closed box. Case 1. The box has a small window, but the glass is fogged. We think there is a red object inside, but we're not sure whether it's a ball or an apple. That's measurement uncertainty. Better lighting or cleaning the glass might help. Case 2. The box makes sounds when shaken that fit several objects equally well. That's model uncertainty or underdetermination. We need different kinds of tests. Case 3. The box is designed so that from the outside, many different internal arrangements always produce the same exact visible effect. No matter how many times we look through the same fogged slot, the internal arrangement cannot be uniquely recovered from that access route alone. That's non-identifiability. These are not the same epistemic situation. One might be solved with better tools. Another might need a different test entirely. Another might be impossible in principle under the current access route. 5. Why the distinction matters. The cost of confusion. If we collapse these categories, we make serious mistakes. Mistake 1. Treating non-identifiability as uncertainty. This creates false hope. It promises that better tools will solve a problem that no tools can solve. Researchers waste years chasing resolution that cannot come. Money is spent, careers are built, nothing improves. Mistake 2. Treating underdetermination as measurement error. This misdirects effort. Instead of seeking discriminating evidence, evidence that can choose between competing explanations, we try to clean up noise that isn't the problem. We sharpen the wrong tool. Mistake 3. Treating model uncertainty as underdetermination. This can lead to premature surrender. Model uncertainty might be reducible with better constraints. Underdetermination might not be. If we give up too soon, we miss opportunities to learn. Mistake 4. Collapsing everything into uncertainty. This is the most common mistake. It lumps together noise, ambiguity, multiplicity, and impossibility. It treats all not knowing as the same. And when all not knowing is the same, we cannot learn strategically. We just flail. A mature science must do better. 6. An example across scales. Let us see these distinctions at work across different scales of reality. At the quantum scale, measurement uncertainty. A physicist measures a particle's position. The instrument has inherent limits. Better detectors could reduce this. Model uncertainty. Two quantum models both fit the existing data. More experiments could discriminate between them. Underdetermination. The wave function collapses upon measurement, but which interpretation, Copenhagen, many worlds, pilot wave, is correct? The evidence underdetermines the interpretation. All fit the observations. Non-identifiability. In quantum mechanics, certain properties are fundamentally complementary. If you measure position precisely, momentum becomes indeterminate. This is not a limitation of your instrument, it's a feature of reality. Some things are non-identifiable together. At the biological scale, measurement uncertainty. An ecologist counts individuals in a population. Some are missed, some are counted twice. Better sampling methods reduce this. Model uncertainty. Two population dynamics models both fit the historical data. More observations could discriminate. Underdetermination. The fossil record shows a pattern of gradual change. Does this indicate slow evolution or rapid evolution with long periods of stasis? The record underdetermines the answer because fossils don't preserve the necessary temporal resolution. The exact sequence of genetic mutations in an ancient lineage cannot be recovered because DNA degrades. No amount of better measurement can recover what no longer exists. At the medical scale, measurement uncertainty. A blood test has lab error. Repeat testing reduces this. Model uncertainty. Two disease models both explain the patient's symptoms. More tests could discriminate. Underdetermination. The patient's symptoms could be caused by three different conditions. All three fit. The evidence underdetermines which is actually present. The exact moment a chronic disease began cannot be determined because early stages are asymptomatic. No test can recover what wasn't observed. At the human scale, measurement uncertainty. We see a friend's face briefly in bad light. We are not sure of their expression. Model uncertainty. Their expression could mean sadness, irritation, or fatigue. Different models of emotional expression give different answers. Underdetermination. Several explanations for their mood fit equally well. Work stress, relationship trouble, lack of sleep. The evidence underdetermines which is true. Non-identifiability. From facial expression alone, their exact inner state cannot be uniquely recovered in principle. A different access route, like conversation, is required. 7. The identifiability principle. Let us now state the principle clearly. A pattern structure is identifiable under a window if, in principle, the available access uniquely determines it. If not, the claim must be qualified as non-identifiable, not merely uncertain. In simpler form, some things cannot be known through this window, no matter how hard we try. Or even shorter, know what cannot be known. This principle protects against false hope. It prevents us from chasing what cannot be caught. It directs effort toward what can actually be learned. 8. Why non-identifiability is not failure. This is important. Non-identifiability is not failure. It is not a mistake. It is not something to be ashamed of. Non-identifiability is simply the shape of access when some things cannot be recovered. Think of it like this. We cannot see the back of our own head without a mirror. That's not failure. That's the geometry of perception. We cannot know what our great-grandmother was thinking on her wedding day. That's not failure. That's the structure of time. We cannot measure both position and momentum of a particle with arbitrary precision. That's not failure. That's quantum mechanics. Non-identifiability is not a problem to solve. It is a condition to accept. The mistake is not having non-identifiability. The mistake is pretending it doesn't exist or treating it as if it were merely uncertainty that more data will cure. 9. An analogy. The far side of the moon. For all of human history, the far side of the moon was non-identifiable. Not uncertain, not underdetermined, non-identifiable. No amount of staring from Earth could reveal it because the moon is tidally locked. This was not a failure of astronomy, it was the geometry of access. Then we sent spacecraft around the moon and it became identifiable. The window changed. This shows something important. Non-identifiability is always relative to a window. Change the window, and what was non-identifiable may become identifiable. But while the window is fixed, non-identifiability is absolute. A mature science must know the difference between what is uncertain within this window, what is underdetermined within this window, what is non-identifiable through this window. 10. The two great errors we must avoid. When we confuse these categories, two great errors follow. False hope. Treating non-identifiable claims as solvable by more of the same. Promising resolution where none is possible. Telling people a better attitude and more effort will solve it when in fact the structure cannot be uniquely recovered under the given window. False despair. treating reducible uncertainty as if nothing more can be known, giving up when better tools or different tests could actually resolve the ambiguity, calling everything unknowable when only some things are. The taxonomy protects against both. It says, some doors can be opened with better tools. Some doors require different tools entirely. Some doors are locked forever, and we must accept that. Wisdom is knowing which is which. 11. The relationship to claim types. Different kinds of claims have different identifiability demands. An identity claim may be identifiable where a predictive claim is not. We may be able to identify that a signal belongs to a known class, even while not being able to predict its exact future behavior. An emergence claim may be identifiable only at a certain scale. The pattern may not be identifiable at the micro scale, but a stable macro invariant becomes identifiable at the coarse-grained regime. An interpretation claim may remain underdetermined even when the underlying structural pattern is clearly identifiable. The text marks may be fully legible, but what they mean under competing interpretive maps remains unresolved. This means identifiability is not a flat, all-purpose label. It must be paired with claim type. What is identifiable, at what layer, under what window, for what kind of claim? Without that precision, we speak too vaguely. 12. A telescope example. Suppose astronomers observe a distant object. At one level, the object is identifiable as a source of periodic light emission. At another level, the detailed internal mechanism may remain underdetermined among several models. At another level, certain fine structural claims may be non-identifiable under the current telescope resolution. All three statements can be true at once. The object may be identifiable in one respect, uncertain in another, underdetermined in a third, and non-identifiable in a fourth. A mature science must say which is which. 13. Principle versus practice. Another distinction is needed, the difference between in principle and in practice. A structure may be identifiable in principle, but not practically recoverable under current resources. That is not the same as non-identifiability. Conversely, a structure may be practically approachable, but still non-identifiable under the current measurement type. For example, a huge combinatorial problem might be identifiable in principle, but computationally intractable. That's a practical limit, not a principled one. A hidden biological cause might be easy to reason about abstractly, but non-identifiable from one blood marker alone. That's a principled limit. We must not confuse impossible in practice with non-identifiable in principle. The remedy differs accordingly. 14. What honest claims must declare. When we make a public claim, we must declare not just our uncertainty, but the nature of our not knowing. A claim should state where material, is this measurement uncertainty, model uncertainty, both? Is this claim underdetermined by available evidence? Is this pattern identifiable through this window, or is it non-identifiable in principle? If non-identifiable, what would need to change to make it identifiable? Is the limit practical or principled? This is not bureaucracy. This is honesty about the structure of access. If a claim is underdetermined, we should not present it as uniquely determined. If a claim is non-identifiable, we should not present it as merely uncertain. If a claim has model uncertainty, we should not treat it as measurement noise. Each misclassification leads to error. 15. What we refuse. With these distinctions installed, we have clear grounds for refusal. We refuse any claim that treats non-identifiable claims as merely uncertain, promises resolution where none is possible, confuses underdetermination with measurement error, collapses different uncertainty types, claims uniqueness where evidence underdetermines, hides the window conditions that make identifiability possible, uses uncertainty as a blanket term to avoid precise diagnosis. Each refusal protects the integrity of our knowing. 16. The deeper meaning, knowing what we cannot know. There is wisdom in these distinctions. A person who knows the difference between what is uncertain, what is underdetermined, and what is non identifiable knows something profound about the human condition. They know that not all not knowing is the same. They know that some doors can be opened with better tools. Some doors require different tools entirely. Some doors are locked forever, and we must accept that. This wisdom prevents two great errors: false hope and false despair. False hope says, we will eventually know everything if we just try harder. False despair says, we cannot know anything because uncertainty is everywhere. The truth is more nuanced. Some things we can know with better effort. Some things we can know with different kinds of effort. Some things we cannot know through this window at all, but another window might open. A mature science, like a mature person, knows the difference. 17. Hand off to what comes next. With identifiability now clarified, we must address another foundational source of uncertainty. Our instruments drift. They change over time. They need calibration. And calibration itself has uncertainty. If we do not understand calibration and drift, all our careful uncertainty declarations rest on a hidden assumption that our instruments are stable. They are not. That is where we go next. Part 54.5, Calibration and Drift, will give us the tools to understand how instruments change over time, how we calibrate them, and how we account for the uncertainty that calibration itself introduces. Because a science that ignores instrument drift is building on sand. 18. Closing meditation. We have added another layer of precision to our growing science. We learned that not all not knowing is the same. Measurement uncertainty is noise. It can be reduced with better tools. Model uncertainty is representational ambiguity. It can be reduced with better constraints. Underdetermination is evidential plurality. It may require entirely new kinds of evidence. Non-identifiability is principled limit. It cannot be reduced through this window at all. These are different. They demand different responses. They imply different possibilities for knowledge. A science that confuses them wastes effort and breeds false hope. A science that distinguishes them proceeds wisely. We are building such a science. Now we go deeper still, into the instruments themselves and how they change over time. Because knowing what we cannot know is only the beginning. Knowing that our tools themselves are drifting, that is the next frontier. Always, peace be upon you.